Let's take a look at what even and odd functions mean graphically. So looking back at these parent functions that we had in previous sections on graphing shortcuts, if we're looking at even and odd functions, what we're also looking at is certain types of symmetry. Even functions like x squared, y equals x squared, have a symmetry about the y-axis. Let's take a look at why that is. If we look at the two even functions we have here, in this case, our two even functions we have listed are y equals x squared. That has a symmetry about the y-axis. And let's see, not x cubed. It's not symmetric about the y-axis. It's more of a diagonal symmetry. But y equals the absolute value of x, that also has a symmetry or a reflective property about the y-axis. Y equals the square root of x is not reflected itself around the y-axis. And y equals 1 over x is kind of that diagonal property symmetry that we'll talk about in a second. So let's discuss specifically even functions and why they're reflective about the y-axis or symmetric about the y-axis. Let's take y equals x squared. If we're looking just at y equals x squared, what I want you to notice that let's say we have an x value like x equals positive 1. And if we go up and over, we would have x equals positive 1 and y equals x squared. We would have y equals 1 squared or y equals 1. But in order to be symmetric about the y-axis, then also when we plug in x equals negative 1, we should get the same y value. We plug in x equals negative 1 to y equals x squared, and sure enough, we have negative 1 squared, which is positive 1 also. And this is true for any x value we plug in. If we plugged in x equals 2, and x equals negative 2 into y equals x squared, we would get 4 both times. Because the negative 2 and the negative 2 would still give us a positive 4. And on the graph, if here this is x equals 2, and we go up and over, here's y equals 4, and same thing for x equals negative 2, although my graphing is pretty bad. I can't draw straight lines. Let's try that again. Negative 2. We go up and over, we get y equals 4. So in general, for an even function, when we plug in negative x, any negative x value, we should get just the f of x back out. We should get just f of x out. The negative for the x, when we plug it into an even function, should simplify away, and we should be left with just f of x. Now, please don't think that just because I have positive 1 and positive 4 here, that's what we're saying. We just have to have f of negative x should simplify to be regular f of x. So let's try a different example that's a little bit more complicated than just y equals x squared. Let's look at the function f of x equals negative x to the 4th plus 3x squared and ask ourselves the question if this function is even or not. So in order to do that, we test it by plugging in negative x. So everywhere we see an x, we'll plug in a negative x. So negative quantity, negative x to the 4th, plus instead of 3x squared, we'll do 3 negative x squared and simplify. So this is going to be, let's see, the negative x to the 4th power in parentheses simplifies to just be x to the 4th. And the negative x squared in the parentheses simplifies to just be x squared. So negative x to the 4th plus 3x squared. And since this is the same function that we started with, it's the same as f of x, then we know that yes, this is indeed an even function. To tie this in, let me show you what a quick sketch of this graph looks like. Here is a rough sketch of what the function negative x to the fourth plus 3x squared looks like. So excuse my my shaky drawing here, but what you'll notice is that this function also is symmetric around the y-axis. It doesn't itself have to be positive all the time, but it does have a symmetry around the y-axis. Okay, so even functions have the property that when we plug in negative x, the negative part of the x will simplify away and we're left with the original f of x. Let's look at odd functions. Odd functions are the ones that have symmetry like an x cubed about what we call the origin. They're kind of a diagonal sort of symmetry. So y equals x cubed would be an odd function. This is not an odd function. Absolute value of x, square root of x is not symmetric about the origin, but 1 over x has a nice symmetry, a diagonal symmetry about the origin. So let's take a closer look at odd functions. Let's look at the function f of x equals 2x to the fifth minus 7x cubed minus 4x and ask the question, is this function an even function, an odd function, or neither? Well, graphing it is kind of impractical, so let's plug this negative x in for x into f of x and see what we get. If we have an even function, f of negative x should simplify to just be the original f of x. And if we have an odd function, f of negative x, the negative should, for lack of a better word, factor out, and we should have negative f of x. So let's see what happens in this case. Plugging in a negative x everywhere we see an x, we have, let's see, 2x to the 2 times negative x to the fifth power minus 7 times negative x to the third power minus 4 times negative x. And we'll simplify all of that. Let's see, negative x to the fifth power is negative x. So this would be bringing the negative out front, negative 2x to the fifth. Negative x cubed is also negative in the x cubed. And bringing the negative out front with the negative 7, that would become positive 7x cubed. And then finally, negative 4 times negative x is positive 4x. So what I want you to notice about this is this function, f of negative x, has opposite signs in every way compared to f of x. Where it has a negative 2x to the fifth, f of x has a positive 2x to the fifth. Where it has a positive 7x to the third, f of x has a negative 7x to the third, and a plus 4x is a minus 4x. So if I were to factor out that negative, I could write negative 2x to the fifth minus 7x cubed minus 4x, which would be the same as negative f of x. So this is an odd function. Let's try one last one. Let's determine if the function f of x equals 5x to the seventh minus 2x to the third plus 7 is an even function, an odd function, or neither. And testing for both even or odd is the same. Plug a negative x everywhere where we see an x. So this will be 5 negative x to the 7th minus 2 times negative x to the 3rd plus 7. And when we simplify that, remember a negative raised to an odd power will be negative. So this is a negative 5x to the 7th. For the negative x cubed is negative x cubed. So that would make this a positive 2x cubed. Ooh, this is looking odd, right? The signs are changing. Positive 5 is turning into a negative 5. Negative 2 is turning into a positive 2. Alas, the plus 7 doesn't have an x with it, so it stays plus 7. So not all of the signs changed, and it isn't exactly f of x. So this is not equal to f of x, and it is also not equal to negative f of x. Since it's not equal to just regular f of x, the function is certainly not an even function. And since it's not equal to entirely the opposite of f of x, it's not an odd function. It might have a different kind of symmetry, or it might not be symmetric whatsoever. So this function would be neither even nor odd.